Hey, what's going on, guys? Kings here. A quick update on BBC Chess Engine development progress. So I was going to implement the dynamic hash initializations a long time ago, and finally I did this. I'm sorry for not making a video tutorial on how to make it. Not typing the code, like not live code in this stuff, because dynamic memory allocation is something that I'm really bad at. So just in order to avoid producing even more bugs, I decided to do this on my own and test everything, make sure it works, and then make this small coverage catch-up video. So you could have downloaded the code and start making use of this new feature of Bitboard Chess Engine that we're now working on. So the very first thing, hash entries. Let me just read hash entry. So here the variable name was not hash entries but hash size, but that was a little bit inaccurate name for that variable, because it's literally the number of hash entries and not its size in megabytes. So it's one little update, so the variable name has been changed. And then if you just try to find this hash entries, so that was they were defined using this define directive, but now it's a variable because we would be changing the number of hash entries depending on how many megabytes has been allocated for our hash table. So that's another update here. Another thing here. So the definition of the transposition table instance itself. So it was an array of a fixed size of characters, and now it's just a pointer that is equal to null, which is like non-initialized, non-allocated memory, something like that. And well, clear hash table has changed. I'll cover this just a little bit later on. First, let's have a look at the new function provided here, which is called initialize hash table. So the idea is to dynamically allocate memory for our hash table. First, we need to calculate the hash size. So this is the hexadecimal value of 1 megabyte. So we need to multiply this hexadecimal constant that is equal to 1 megabyte to the number of megabytes we have. So we have this hash size holds the value of how many megabytes we need to use to initialize our hash table. Then we're calculating the number of hash entries by dividing the hash size, this megabytes, by the size of a single entry of the transposition table instance. And then if hash table, so if this sort of a pointer, this global array, if it's not equal to okay, I'm sorry, yeah, it's here. If it's not equal to null, it means that it has been initialized before. Hence, we need to clear the hash memory. And this is what we're doing here. And here we're clearing this dynamically allocated memory, which is quite pretty important thing to consider. So the next thing, we actually so yeah, if from the previous kind of part, if from the previous change this hash table wasn't clear, we need first to free the memory, and then we just allocate new memory. So I'm using this memory allocate standard C function. So we're multiplying the number of hash entries by the size of our transposition table. So literally allocating the number of hash entries to make a hash table kind of array of the size of this hash entries, and every hash entry is the size of the instance. Is equal to the size of a single transposition table entry, which is quite pretty self-explanatory, I hope. So the next thing, so if after this allocation hash table is still equals to null, this means that something has gone wrong and we couldn't allocate the memory for a hash table. And in this case, we're trying to have the size of the megabytes. So this is the implementation I've taken from Vice Chess Engine. So it works, kind of works there. Okay, hold on a sec. Something has been wrong with my location here. Okay, just sorry for this, guys. That's because I've already changed the name. Of this folder here. So init hash table. Okay, like this. And we're trying to allocate this half size here. Otherwise, if everything is just fine, we need to clear our hash table, like to set all the entries and all the sub entries to zeros, and we just then print the successful message that everything is kind of fine here. And now an important change in clear hash tables. So instead of looping over the indices, well, even though probably that was possible as well, assuming the nature of arrays and pointers in C programming language, but just for clarity, I've used the implementation by Richard Olbert, also known as Bluefever software, just like I did in Vice. So I just initialize the hash entry pointing to the hash table, and then in case if hash entry is less equals then hash table plus the number of hash entries. So that's here we're dealing with the particular memory addresses. So in this until it's less, we're incrementing our hash entry. So that's kind of the idea here. And then we just initialize all these hash keys to 0, and that's kind of how it works. Another little thing, I just remember that in Wise there was some little trick here. Yeah, I just need to check that out. I'm not now ready to handle that. Okay, guys, just sorry for my thoughts on the background of my consciousness. So this is how it works, and now we just go to our UCI loop. Before we go to our UCI loop, I also want to show you this init all function. So now by default I've removed the clear hash table from init all, because now it would have been called within this init hash table. So clear hash table is called from this init hash table, like been shown already. So we are initializing hash table with a default value of 12 megabytes. And actually, hold on a second, I'm just also thinking, so 12 megabytes is something that Arena is using by default, at least on my system. So probably I should have set this to 64 because I want 64 to be the default value. So I'm not sure. Yeah, probably I should set this to 64. And now I just go to the UCI loop itself. Then, okay. So we've added this print statement to point the default, the minimal, and the maximal hash size, which would be equal for now like 128. I'll probably later on I will make this make it bigger, but for now it seems to be literally enough here, fairly enough here. And also a new option. So also we can now set option name of the hash with a given value. Here we're just parsing our value and adjusting the megabytes, which is the so here we have two additional variables like maximal hash size and the megabytes, which is by default is equal to 64. So here we just checking out if the number of megabytes is less than the minimal number, then we set it to minimal number. If it's greater than maximal number, then we set this to maximal number. So this is quite pretty simple. And finally, we just print that we actually set this to that we actually do set this megabytes, and eventually we initialize our hash table with a new value of megabytes that is available. I also need to double or maybe even triple check this code to make sure that I didn't miss anything, because I just remember one little thing that I saw in Vice's implementation, but I'm not sure if I need to duplicate this here in BBC or not. But anyway, I want to show you the current version of BBC that you've just seen, that corresponds to the source code that you've just seen. So let's go to the engines, and here within the UCI options. So I tried this 128 megabytes, So in this case, let's say we're just starting the game with BBC playing versus Vice, then okay, something has gone horribly wrong. Let me just restart my arena. I'm not sure why it didn't work. It was working just right a moment ago. Okay, so let's try to play. So yeah, I need to refresh the link. Sorry. So engines. Okay, new game. Yeah, I just need to refresh the link. Yeah, sorry for this. Okay, apply. And yeah, you see like the number of megabytes has been adjusted. The reason why it's not 128, that's because it just prints all the memory used by the engine, but all the rest memory, like this number minus 128, is the memory that is used by all the variables within the engine itself. So it's not a transposition table. So transposition table is 128 megabytes, and that's kind of it. So you just ask our engine to play a game, then after going away from the opening book, it actually starts playing chess, and that's kind of it. So if we just now try to go into manage engines, UCI options, and let's try to have, let's say, like, I don't know, let's have 64 megabytes and apply, and the hash size should now be changed. It's a little bit strange what has just happened to Vice. I'm not really sure. Yeah, this is a little bit strange. I'm not sure what has just happened to Vice. Okay, both engines seems to be behaving a bit strange for some reason. I swear I've been testing this before this video, and it was working just like a charm. I have no idea what has gone wrong now. So engines manage UCI. Oh, just horrible number. Okay, so I want 64 megabytes. Apply. Okay, and let's try to play. So hold on a sec, this is a little bit strange. Hold on a sec, guys. I'm not sure why this is happening, to be honest. So it wasn't like like this, I swear. Okay. Let's try. Okay, let's try 100 megabytes. Okay, so now, yeah, it has been done perfectly well. Okay, so why did it? Okay, and engines manage. I'm just wondering. You know, I've never used these features as a user, I swear, because I can't see much reason in that, to be honest, but I know that people request this kind of like features. Okay, so 12 megabytes is set up correctly. Okay, it's a little bit more due to the reason I've been explaining already. Okay, and let's actually, again, like, why didn't it set up the 64 megabytes? I'm a bit wondering. Okay. Okay, now it's set up correctly, so that was some misclick or something. So yeah, now it has been set up correctly as well. Okay, guys, so this is it regarding new feature of dynamic adjustment of the hash, and I would also, again, like, triple check everything to make sure it works as expected. I've already tried some small tests. It still kind of plays chess, which is really good news. But anyway, really need to make sure that everything is just fine there. So this is it from my side, and new tutorials on improving BBC strength are coming soon, basically. But before that, obviously, I need to learn lots of new things on my own. And also another important announcement. I'm gonna run some Blitz game tournament, Blitz game match between Vice and BBC this night, and if BBC doesn't crash, if everything goes just fine, and if the results in Blitz are as good as in Bullet, as I've published in the previous video, in this case, I will release the version of BBC, the version 1.1. So this is it from my side. Hope you've enjoyed the video. Hope to see you in the next tutorials within this Bitboard Chess Engine in C series. Until that time, and take care, guys.